Good evening, everyone. I'm Samir Maskey, and I'll be talking about customer service automation with data science and AI. A little intro about myself. I'm founder and CEO of Fusemachines. I also teach data science, machine learning, statistical natural language processing in Columbia University. The company was founded about 2 years and a few months ago, where we built a customer service automation platform. Before I delve into too much detail on the customer service automation, I would like to ask a question to all of you. How many of you have had this experience when you call the call center? Many of you, right? And probably most of you. Today or this week or last hour, right? And you probably heard that sentence so many times, probably you remember by heart. We are sorry to make you wait, and blah, 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 and so forth. So why is that? Why, with all the advances in technology and so forth, customer service is still broken? That is, when you call to the call centers, you still have to wait 15 minutes, half an hour, 45 minutes or more. The longest call I've waited is 60 minutes when I call a cable company, who are particularly tend to be bad. And if you try to look at this problem, we could see two possible reasons for that. One is a difference in resource between the number of calls that come to the call centers and the number of people who are working in these call centers as customer service reps. So 42 billion calls come to call centers in a given year. That's a lot of calls. Slightly less than 4 billion calls a month. And we do not have enough number of customer service agents answering those calls. In an ideal world, there will be so many people answering calls that within a few seconds someone will pick up and then just you'll get the answer what you're looking for. So, but that's not the case, and it's not easy to solve. We can't just keep on hiring more customer service reps in customer service department. So the other solution, potentially other solution, would have been a technological advancement so that call center is automated to a degree that you could get answers from machines. While the self-driving cars are getting close to reality, we're still so far from talking machines. And by talking machines, I'm not talking about Siri where you ask a question and it answers sometimes and does not answer sometimes. I'm talking about machines that can really converse with you. You can sit down and just talk, like the machine in movie Her, which I'm hoping a lot of you have watched. So why is that? Right? Why hasn't the technology advances in machine learning and so forth hasn't gotten to a point where we have systems that can talk like humans? Turns out we are really, really good in learning languages. If we are, like in last 5 minutes, I've spoken so many sentences already, right? For a machine to create a sentence out of 10 words, it has to go through 1 billion permutations. That's a lot of brute force search you have to do to put 10 words together to form a sentence that has some meaning that you want the machine to say with the intended meaning and content. But for us, it's very easy. So machines are not there yet. We don't have a true conversational machines. But does that mean that we cannot do anything from all the advances in machine learning and AI to automate customer service to a certain degree? And our answer as Fusemachines is yes, that we can do a lot of stuff with all the data that gets generated in customer service world. So if you look at this map of customer service, these are all the different channels that any customer will talk to a customer service rep in a customer service department. Someone might come to the web and try to browse the website to find an answer. Someone might send an SMS asking for information. Service agents get good emails, which could turn into tickets, which gets transferred to different customer service reps. So all of these places where there are social media channels where someone's shouting at a company for having to wait for 60 minutes, you know, that's a data piece that's generated and gets turned into customer service reps. So that's a lot of data that gets generated at various different channels, at various different touch points between the end user and the customer service rep. So what can we do with this data to improve customer service? And that's the fundamental questions we are answering at Fusemachines and trying to do better customer service. And in order to answer that, we could particularly focus on two core things that comes with customer service. One is self-service. Self-service where customer don't have to call and have to talk to anyone. That's, a lot of people would say that's the best kind, where you can just find the information you're looking for by yourself. So providing superior automation experience. That's one part of the whole customer service game, while the other part is improving or empowering the customer service agents that work day-to-day in the customer service departments. How can you provide tools based on all this data and machine learning to help them answer questions efficiently and fast? And these are some examples from previous slide where there are all these touch points that are generating data, on top of which you could add machine learning layer to improve customer service. Providing automated answers or predicting the next best action a customer service rep has to do without he or she having to think a lot, reducing cognitive load. So let's focus on first on the self-service. And I would like to take you through our demo video so that I could explain as I show the video on how we get all this data and what kind of things we do with it. So this is a system that New York City deployed. This is our system. They deployed it last year. And New York City has lots of departments trying to help New York City residents. One of the departments is business solutions, which tries to help all the New York City residents to open businesses, try to get help in finances, get legal assistance and whatnot. And if you go to the website, there's a lot of content. You have to browse through all of that, through layers and layers of information, and a lot of time people don't end up finding information they want, and they end up calling. And in order to solve that, that's what we deployed. We come up as a small window at the bottom of it, which when you click, you see these related questions based on the content that the user is watching. Now, if somebody was here to try to open, let's say, open a restaurant, they could just start typing in a few letters, open up, and it pulls up all these questions in natural language forms that they are interested in, and they can just click the questions. Now you see that somebody just said, how can I open a restaurant? In a very natural language form. And it gives you a list of all these permits that are required to open a restaurant. There are tons of permits that you require to open a restaurant, apparently. So that's the answer in a very natural language form. Besides providing the answers, the machine is also predicting, based on the context and the question you ask, what are some of the other questions that might be of interest to you. So here, just now, it showed you a related question that if somebody's applying for a permit, they're probably also interested, how can the permit be denied? The system automatically picked that up and showed them, and they just clicked on that. And they were able to see the answer. So that's one way to improve self-service, taking lots and lots of information that is embedded deep into web structures and other kinds of documents and web forms and PDF files, and allowing people to ask questions in natural language form. Similarly, you can use the same technology inside SaaS platforms. So there's a lot of SaaS companies out there, and a lot of SaaS companies keep on adding a lot of features based on a lot of user feedback. It gets pretty complicated to use very difficult softwares with a lot of features very quickly. So what this does is, this is a context-aware system which looks at what the user is looking at and automatically predicts what are some of the key questions that the user might be interested in. So somebody was looking at leads, and it automatically figured out the whole bunch of questions about leads. Let's say somebody goes to a different page in the SaaS platform, and they have questions on how to do stuff with contacts. As you can see now, the questions are all about contacts, and similarly, somebody might go to campaigns page, and they suddenly get all these questions about campaigns. So essentially what the system is doing is it is looking at the context, what the user asks, what the user is looking, what are all the different types of information user is seeing, and based on that, automatically predicting preemptively that these are some of the questions the person might have. So let me just show them right away so that they can see it and they don't end up calling. So those were two ways of collecting data that is in this complex layer of web structures and other PDF files and all the unstructured data, and bubbling that all up so that you can ask questions against it in a very natural language form that is easy for anyone to do. And if we look at the slide before, so this is what we're doing, right? We were looking at the context data and preemptively displaying information that's relevant and providing automated answers for emails and so forth. The question is, how do we build a system? I just explained how it does, how it predicts, how it's context aware and so forth, but how do we build it? Where do you start with? Like when I go and talk to a client, what do I say? So the first thing the system does or needs is the seed data. It requires seed data that could be in different forms. It could be structured and unstructured data, and it could be in question-answer form, or it could be just tons and tons of ticketing data where tickets have been sent to the customer and someone in the customer service rep department have answered those questions, where the system could automatically extract those questions and answer pairs just based on customer service tickets. And in fact, that's something we do. Based on time, I'm not going to go through all the demo for building the system, but there's Zendesk integration, Salesforce integration, and so forth, where you integrate our system with the Zendesk account. It will pull up all the ticketing data, all the chat data, all the Twitter feed data, and all the questions and answers that are embedded deep inside it. It does predictions on association or questions and answers at sentence level, pulls them up, and feeds them to build a system. And so once you have the seed system with certain amount of knowledge, the system keeps on improving based on customer interactions. So the more customers ask, the better the system gets. And the way it works is if the customer asks something in topic and the confidence score for the machine learning algorithm is low enough that the machine thinks this is something that as a machine I should be able to answer, but I cannot, it flags it and sends it to the managers who add more knowledge to it, and it keeps on improving every day. So that's one way to improve self-service, by pulling data in all different forms that lies in customer interactions and bring it to a form that improves self-service. The next I'm going to talk about is how to improve Support Center by using the similar algorithms and similar kind of data, but to empower the customer service reps in the customer service departments. And I'll do it with the demo videos again. So one of the challenges in improving customer service department is training a lot of customer service reps as fast as possible. A lot of very large call centers have high rate of churn with a lot of people coming in and going out because, frankly, it's not the most fun job to answer calls day in, day out, right? So there's this huge problem of training customer service reps. So what we did was, well, we said, we have this system that keeps on learning from the interaction with end users. Why can't we use all that data to actually train the customer service reps using AI system? So this is a conversational system where you can, the trainee customer service rep can pick a topic, and then the customer service rep the AI system will ask you a question, and the customer service reps will type in an answer from what they know, or they could look up different PDF files and documents And the system will take the answer and automatically figure out, well, how good the answer is and give a score to it. All right, so let me fast forward a little. And so it will try to do the conversation. It will keep on asking more questions, and it will keep on scoring. So what this does is basically a very efficient way for any new customer service rep coming in. All they have to do is talk to an AI agent, which already knows a lot of stuff about the product, about the company, and all the questions and answers people have been asking through emails, tickets, web forms, and the widget itself. Right? You could take all that data and be an AI agent, expert AI agent, training the customer service reps. And the other piece of the puzzle on improving the customer service department with the data that's coming in is how to help the customer service reps to efficiently find the information. Right? So this is a 3-layered search where you could quickly zoom into a particular document that the company had generated for the product or whatnot. And particularly these small features like in-depth search that quickly zoom into a particular section of the document where you could search for a particular word or a particular few letters really helps someone while they're on the phone to find the information they want. And the things you see on the left are the tags that are predicted for those documents. And they are actually automatically generated. So when you upload these, when the customer service department uploads these documents, you have to manually classify or tag some documents as part of the training data. After that, it automatically learns and automatically tags them, giving you 1 minute. The data. So I was going to show you more stuff where the speech recognition system runs automatically to do continuous search while they're on the call and so forth. But I'm going to skip some of this part of the demo so that I can go to the rest of the talk. So essentially, what we are looking at is looking at all this data that's just generated between because of the interaction between customer service agent and the end users, and do things with it. And the way we look at it is this data is in 2 different categories, unstructured and structured data, and things we do are ranking, classification, and clustering. And I would like to say these are one of the 3 fundamental problems in machine learning. That is, given data, how do you score them? Given data, how do you label them? And given data, how do you cluster them? If you take these exact 3 fundamental problems and look at in the customer service automation world, data to scores basically means we are taking data and giving automatic answers or automatically ranking a new piece of information. Data to classes, predicting answer types. So for example, when the machine you saw predicting giving answers, it has to automatically predict what the answer type is. Is it a list? Is it a location? And so forth. So these are examples of classifications. And data to clusters, where you cluster customer service customers' data. I have 3 more slides where this is showing how the data and the machine learning algorithms comes to life as a set of features in the product, where you are ranking these questions based on the context, classifying them to do automatic labeling, and clustering them to come up with these filters. So lastly, what I would like to say is we are not at the point where we have fully automated talking machines that can converse with humans as we do, but there's a lot of data that gets generated in each of these touch points that you can take and build layers of AI and machine learning on top of it to do some level of automation to improve customer service. Thank you.
Thank you very much. So since we're a little over time, let me just go directly to questions if people
I have a quick comment to make. Genius, or formerly known as Rap Genius, they're using annotation technology for users to annotate the news.
Yeah.
So I was curious whether you looked into that and whether it'd be possible for you to utilize that as well to annotate content like the government site, so that like other people could maybe comment on something that other people could read.
So what you're saying is community-generated tags that could be automatically put into the system so that it learns from that as well?
Yeah, so the users could annotate that, and you could use your natural language processing as well to...
Yeah, so that's definitely possible. And what that would entail is how to mix the tags that are generated by very qualified people within the company who know the product versus less qualified people who are just users who are just commenting or tagging, which may be more noisy. So you could do classifier combination, some sort of classifier combination that automatically takes the tags generated from the community users with slightly less weight and put them together to reduce the error during the training process.
Great.
I was wondering whether you've looked at using this technique to address issues of regulatory compliance, have same sort of factors of being able to interpret lots of regulations, being able to use it for training, for complex queries, and so forth.
A very good question. We have looked into, but not as in Fusemachines, but me and another faculty in CIPA at Columbia, where we have looked at all the legal documents put out by Congress and tried to figure out various degrees of compliance and the power vested on different structures within the government, which is a very different topic, but this can be used, but the algorithms change slightly because data changes slightly.
Quick question. More companies are thinking about using their customer service reps as a sales channel. And I'm curious if you've seen that application, with any of your clients and how you might try to predict whether a customer service call is actually a sales opportunity.
So we have had customers ask where they wanted system where the system would send out these batch emails for lead generation and lead qualification and try to do this coordination over the emails to do the sales. So we have had those requests, but we haven't built them yet. So one of the things I haven't shown you yet is the additional new model that is coming in the Gendesk integration is automatic response generation, so that the system would actually look at the ticket and would suggest to you the full response. And if you like the response, you actually don't have to type the whole thing. You can just click a button and then submit the response.
Let's say I make a call, and my call is, when's my next garbage collection going to be? Obviously, you need more information on that.
Yeah.
How does your system handle that? And does it try to create an interaction, or is it just give me a list? If you live in this borough, it's this. How do you deal with this?
Yeah, excellent question. So what time is the garbage collection? How late is the train? Right? These are all live data, particularly structured data that lives in various forms of databases that you have to connect to provide an answer. So one of the first things in the beginning that we have avoided is to connect to all these structured databases at different companies and having to do all this manual integration to provide answers like that. So, we don't handle those questions, particularly for New York City government. If you answer questions like that, it would just say, I couldn't find the answer, and it will transfer it to a human agent.
Great. I guess last question from me, and just completely switching gears. So you're with Columbia, right, as well?
Yeah.
What's going on there in terms of the whole data science training? Is Columbia training the next generation of data scientists? And do we have anyone here? How do we bring them here? And how do people hire them?
They are. I mean, there's Data Science Institute, which is offering degrees on data science itself. And it's a multi-department consortium where there's faculty from all these different departments. And data science particularly is multidisciplinary. I wrote a blog a long time ago called Three-Headed Data Scientist, that in order to really be a data scientist, you need to know engineering very well so that you can process all forms of data. You need to know machine learning also very well, which takes many, many years of training. And you also need to know all these user interfaces and how to visualize data. Training data scientists are hard, and that's why it requires multidisciplinary effort, and that's what's been done at Columbia with Kathy McCoy heading the department. And there are more and more data science students that will be graduating who can